Alright, back for more. Talking about GPS. This is Module 10. Last time I kind of talked about the basic concepts associated with GPS, where the GPS receiver, notice not transmitter but receiver, receives a signal from a satellite. It uses the timestamp in that signal, compares it to the time it receives the signal, multiplies by the speed of light, knows how far away it is. If it can hone in on 4 satellites, it can specify its location on the Earth. Bunch of acronyms. If you want to get in deeply, you can learn all the acronyms, and then when you read a sentence that has 5 of them in it, you'll be able to understand what the heck the sentence means. Navstar is the United States version of GPS. It has 3 segments: the space segment, the control segment, and the user segment. The space segment, that's made up of the satellites, and there are somewhere between 24 and 32 satellites orbiting around the planet. They're in 6 different orbital planes. They orbit at 12,600 mile altitude. The orbital planes are 60 degrees apart longitudinally, and they're inclined 55 degrees to the equator. Each of them goes around the planet about twice a day. That works out so that there's going to be at least 4 satellites within the line of sight of any spot on the planet. So we've got all these satellites. They've been being launched for a long time. They've slowly built up to the number that they have now, and then as satellites become old and unhealthy and go past their lifespan, new ones are launched. So you can see that there are a bunch of different varieties of satellites out there. It looks like the 2As that were launched from 90 to 97 are the last ones that are still somewhat healthy, and they're continuing to launch new ones all the time. This is a graphic that kind of shows the orbits, 24 to 32 satellites. The colors here are associated with one of the orbital planes, so if you imagine this is an orbital plane, there could be 4 to 6 satellites orbiting in that plane. And then if you imagine this red line rotating 60 degrees about the axis, the north-south axis, there's going to be another orbital plane, another 4 to 6 satellites, and on and on and on. Okay, the control segment, that's used to make sure the satellites are where they are, to keep them set up with good synchronized clocks, and to have them running properly so that they can send the signals out to the receivers. There are a whole bunch of pieces to this. Remember that the Navstar GPS was developed by the U.S. military, and it's kind of managed by the Air Force still. So they have different types of stations. They have the master control station and an alternate, and they have antennas, tracking stations, and monitor stations. So these stations are what they use to keep track of where the satellites are, how they're operating, sending information to the satellites, and making sure that they have the right orbits maintained. The user segment is the receiver. Okay, the receiver is the handheld or the phone unit that you have that's going to triangulate based upon the signals it receives from the satellites. Single receiver are the basic receivers, the basic handheld and phone receivers. They receive one frequency from the satellites. The satellites actually broadcast on 2 different frequencies, so there are also dual receivers, and those are broadcasting on 2 different frequencies, and in the next video I'll talk a little bit about errors, but dual receivers are going to give you a better locational precision than the single receivers. In addition, dual receivers, like single receivers, can do static relative positioning. That's the basic triangulation, but they're capable of doing what's called differential GPS, which allows them to compare the signal that they're getting to the signal that a known spot on the surface of the Earth is getting, and correcting any errors that might be introduced into the signal as it's coming through the atmosphere of the Earth. I'll talk about more of that in another video. Okay, the United States isn't the only country that has a global navigation system. The GPS system is from the United States. The GLONASS is from Russia. You can see that this is being restored. I'm not quite sure how up to date this chart is, There's also one that the European Union is developing, the Indians are developing one, Japanese, and the Chinese. Now these are all at different levels of deployment, but some of these have enough satellites deployed and they're starting to share information so that receivers that were maybe developed for the United States version can actually access signals that are sent from other versions. So we're going to get more and more precise positioning as more and more of these satellites get up there. Okay, Navstar, that's the United States one. Again, 24 to 32 satellites, 6 orbital planes, 12,000 mile altitude. And the key to this is at least 4 satellites are within line of sight of any given point of time, unless you're in a canyon or under trees or indoors. So you should be able to precisely locate your position on the surface of the Earth. There's a website called gps.gov, and you can learn a whole bunch of stuff about how it works by going out there. There's a lot of information. You can see where all these acronyms come in and what they mean just by going out and learning more at gps.gov. Okay, next time I need to talk about GPS errors. The signal that comes from the satellite can get distorted in ways that make the signal not quite as exact as you might like it, and so those errors can be corrected. And the next video I'll talk about how you can correct those errors.